So this is my explanation for the lemon electrochemical cell interactive concept for this week. So this is my setup for the concept. So finding the materials for this was a bit precarious, but I used copper nails. I had fine steel wool, stripped insulated wire, and then I also used zinc panhead machine screws. I was going to use a galvanized metal. I couldn't find anything that was actually labeled galvanized, which was weird. Maybe I just missed it. But I did find some zinc screws, so I thought the whole point was to use zinc, so hopefully these would work out. Obviously lemons, and I used 18 gauge copper wire. So this is my setup for the electrical chemical cell. As you can see, I diagonally connected with the wire the copper screws and the zinc, the copper nails and the zinc nails. And these are the cathode and the anode. So this is a model of an electrical chemical cell using a lemon, and this is because this cell is using a redox reaction to power the reaction that would be the fire, starting the fire. So this would also be called a galvanic cell, because it uses electrolytes in a reduction oxidation reaction. And so the electrical potential of this cell is 5 volts, and the electrolyte used by the cell is the lemon juice, and there are many hydrogen ions there. So for one end of this cell or battery is the zinc right here, and that is the negative end of the battery, or also the anode of the reaction. And so here zinc is oxidized and releases 2 electrons, and copper is the cathode of this reaction, the positive end of the battery, and hydrogen is reduced to form hydrogen gas, so it gains electrons through the electrolyte solution here. They interact. I'm going to show you my videos of the experiment to kind of see what happened. So this is have the steel wool here. I originally used toilet paper. It wasn't catching, and I thought that lint would be more flammable, so I tried that.
Nope, you're just supposed to touch them on 2 ends of the steel wool.
And I found that it wasn't, that was my first attempt. And here's my second attempt. I tried using a finer amount of steel just to see if that would make a difference, and I repositioned or put the nails deeper into the lemon to see if exposing the nails to more of that acidic solution would help the reaction occur faster. I played at this for a while, and unfortunately, I didn't get a reaction, which was a bit disappointing considering I thought that this would have been a really cool one to work out. So as you can see, my experiment did fail. Several things I did mention before. I wasn't sure if my materials were the best to use, I guess. Maybe I shouldn't have used the screws. I should have tried to find the galvanized nails instead of the zinc screw. I also read somewhere that amalgamated zinc doesn't degrade electrons in acidic solutions as well, so I'm not sure if the screw that I use had amalgamated zinc, so that's possibly why. And I did mention that I did toilet paper and the laundry element to see if any would be more flammable than the other. And another is I did go to find some thin wire, and maybe my wire that I used to connect the zinc and copper nails and screw was too thick. I don't know if that has anything to do with it, if it didn't have enough contact with the nails, even though they all were in contact. So I'm not really sure where this went wrong, but these are just some of the things that I speculate happened. And so in summary, this concept should have demonstrated how reduction and oxidation reactions work together in galvanic cells to produce energy, and the zinc oxidized inside the lemon should create energy as a flame or source of electricity to ignite a fire in the toilet paper and seal wool. So I like the idea of this, and I just wish that it would have worked out. Thank you.